What I want to do today is just do a bunch of examples because, when you turn in a homework, what do we typically do? We assign another one, right? And so what I want to do is now that we understand kind of the basic math, I want to drive home a couple points. You also got a file sent to you today that should have two files, should have an RMD and it should have a CSV file.
I
And we're
also
gonna play around
just
with that.
yeah, and I also just posted that in the module sent 6 course content in both BUDA 450 and Accounting 493. So if that's quicker for you to get to than your email, it's there as well.
Cool. And we're gonna play around with that after we finish these two examples today. What I want to do is I want to spend time kind of piecing everything together and let you see what one full analysis with multiple predictors looks like, and then do another one right off the bat, okay? And we'll kind of do it like what we did with those homework examples. The first thing I want to ask you guys, are the examples we do in class helpful for you all? Like, do they kind of drive home the point? All right. You guys are the 20 that are here, so we're going to go ahead and make sure you get your say in this. Today, remember, my goal with this stuff is to, and I know it's all of our goals with this stuff, is to teach you the concept and then drive the point home when we can, okay? So teach you the concept and then do examples to drive the point home. So if you have questions of where we're going, like as we're going through the examples, I'm going to try and type some stuff out like we did with the last one. So you guys have that base to work off of your homework. But for me, it's always hear it, learn it, or hear it, see it and do it, and then do one on your own, okay? That's kind of how we break this out. So what we're going to do today is you're going to see it and do it at the same time. Now, I gave you the orange juice stuff. I haven't given you this yet. Why? Because I want you focused on what the small differences are, okay? What I'm going to do is I'm going to run the things we've done previously in parallel with what we're doing right now so you can see the changes and hear the way we talk about it different. You guys with me on that? All right, let's go work for a little bit here.
And you are going to send us what you haven't, like what you're about to do, right?
Absolutely. Absolutely. You guys don't have to try and code along with me. You guys will get all of this. What I want you focused on right now, and let me say this again, you don't have to code along with me. What I want you focused on right now is what we're talking about and what the code does. Now, this is being recorded, so you're going to be able to go back and hear it again, right? But what I don't want you focused so much on is the syntax as much as why we're doing it, okay? Because again, at the end of the day, we're solving problems. We're solving problems. Now, I want to start where we left off in this example. Let me get my chat up here. All right. So what we're going to do here is we're going to go back to the credit data. And just to remind you what we did, we looked at the relationship between limit and rating, right? And what I said was, look, the whole goal of this analysis isn't to explain your credit limit from your credit rating. It's to explain what balance, if you carry a balance, how much is the balance? And how does that relate to your credit limit and your credit rating, right? Because what we want to do, these are things that get set typically. We get to set your limit. Your rating is something we're able to calculate, right? Or somebody gives to us depending on how you do it. But your balance is the thing that I can't control. So what I want to know is how do those two things relate to balance? Y'all with me on that? Now, as we move through this and as we continue to look at it, something I want you to see and something I want you to continue to think about is what does that mean? So when we left off, here's where I left it. I said, look, we were going to subset the data for credit and we were going to look at all balances that are positive. Now, just as a reminder, the credit data is in the ISLR package, okay? The credit data is in the ISLR package, and it's about basically individuals and their credit cards. So, and how much balance they carry. So here's your income, here's your credit limit, here's your credit rating. How many cards do you carry? What's your age? How many years education do you have? What's your gender? Are you a student? And then are you a student? Are you married? What's your ethnicity? And then what's the balance you're carrying? All right. So basically anything and everything you want to know about a credit card or about somebody who's carrying a credit card, right? So again, what we're trying to do here is use balance as the response, right? We're trying to understand balance as it relates to the other predictors or the other factors. So what I'm going to do is I'm going to come down here. All right. I'm going to start down here. And the first thing I'm going to do is I'm going to filter out all the balances that are greater than 0. I'm going to save everything that has a balance greater than 0 because my question isn't, okay? My question isn't, is your balance 0 or not? The question is, given you have a balance, how much is that balance? Okay, So that first statement, that given you have a balance, restricts everybody we're talking to, right? It restricts everybody we're talking to. It says, look, I only care about people who carry that monthly balance. I don't care about anybody else. All right. And then what I want to do is I want to start looking at, hey, how does credit limit relate to balance, and how does credit rating relate to balance? Now, these are the two plots we left off with last time. So let me do this. Let me do plot credit 2. Now, remember what this is called. This is called a what? Scatter plot matrix, right? Rows are my y-axis. So if it's in this row, it's income on the y-axis, and the columns are the x-axis. So this is the relationship between income and limit. Now, where I want to look is I want to look right here, because this is, excuse me, I want to look right here, because this is balance on the y-axis, because we're in that row, limit on the x-axis, and rating on the x-axis. So these two plots. Now, I know you can't zoom in on them, but first glance, we see a positive relationship there. You guys with me on that? See that positive relationship. But here's what we have to come up here and look at as well. What's the relationship between limit and rating? All right. What's the relationship between limit and rating? Well, what it says is there's a positive linear relationship between limit and rating. Awesome. But each one of those are positively related to balance. So where we left it last time was, how do we build a model? Well, the first thing I want to do is I want to start off by saying, look, I'm going to create something called model limit, which looks at balance against limit, data equals credit 2. Now, all I'm going to do is I'm going to look at summary MLim. Okay. Now, here's what this says. This is our simple linear regression model. What it says is, look, we go a couple different places here. First eyes go here. That p-value says what? It says the relationship between balance and limit is significant, right? There is a relationship. The slope of limit is non-zero. So what does that mean? It says for every 1 unit increase in limit, for every $1 increase in your credit limit, we see that your balance increases by 0.1605. That's 1.6 times 10 to the negative 1. What that means, let me say this very specifically. It means, let me write this out for you. We're saying limit, or we're saying your balance is equal to limit, negative 2.093 times 10 squared, which means 100, which means we move it to here. So your balance is negative 209.3 plus 0.165 times your limit. That's what we're saying. And I got to be able to spell at some point here. Now, this is my equation. What that's telling me here, right? That p-value tells me what? It tells me the slope is non-zero. That's what I need to say. Look, there is a relationship between balance and limit. Duh. But what it's saying is, look, for every $1 you increase limit, we expect your balance to increase about 16.5 cents. That's something useful. If you're trying to get someone to carry a balance and a higher balance, because you make fees off of that, right? You make a percentage off of that. This gives you that ratio. What rate, if we increase that limit, what rate, how much more balance are they carrying? And then I can backfill into my percentage, right? If I know I'm charging 16% interest, if I know what their balance is carrying, I can then adjust for every $1 limit increases, right? And that's great, and that's wonderful, and that's useful. We come down here, we say, here's our R squared. What's that mean? It means limit explains about 63.5% of balance. There's a good, relationship between them. We can come in here and we can do some plots. All right, you can come in here and you can say, let me do it right here. You can come in here and say, look, I want to plot balance against limit, data equals credit 2. And I just want to do that quick AB line. And when I run this, AB line, not lines. And when I run this, here's what I see. Not too bad of a fit, right? That's my interpretation of my line. We also have one more plot that we can use, and we talked a little bit about this last time. We said, look, I have something called an effect plot. What I can do is run plot all effects, mlim. And what this is going to do, okay, is it's going to show me that same plot. But what it's going to do is it's going to say, as I change limit, how does it affect balance? Since I only have one predictor in this model, those are the same plots, right? This plot becomes very useful when we move to a multiple linear regression perspective. All this is saying, look, here's the line and here's the confidence interval around balance. That blue line is my regression line. That gray space or that light blue space is my confidence interval. Sam, what's up?
What are those like little, like on the x-axis, what are those like little like lines at the bottom?
That's where your data is. So you see how this, what it's telling you right here is there's a data point that corresponds to limit at that value, okay? So what it does, those little tick marks down there show you where a majority of your data is, right? So all it's doing is basically saying tick, 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 tick about where the density is. See how you have more confidence, you have that tighter interval right here, right? That goes back to what we've talked about with confidence and prediction intervals, where we have much more certainty where we have a lot of data, right? And less certainty where we have less data. That's all this is telling you. You guys with me on that? So all we're really saying in the major takeaway from this model is, look, for every dollar you're going to increase limit, we expect balance to increase about 16.5 cents, given you keep a balance. You guys with me on that? So for people who keep balances, if we increase their limit by $1, what are we expecting to see come out of this? We're expecting about a 16.5% or a 16.5 cent increase on their balance. Everybody good with that? All right, so that's great. But what this tells me when I come back up here and look at this summary, right? When I come back up here and look at this summary, is that with one predictor, with limit by itself, I can explain about 63% of the variance, which means I have 37% of the variance I can still explain. So let's put another predictor in. Now, the one we talked about was rating, right? We put limit in. We said we still have rating out there. Now, based on what you know and what we've talked about all week, if I have credit limit in the model, and we know credit limit and credit rating have a strong relationship, should we put credit rating in the model? Think about it again. Credit limit and credit rating have a strong relationship, right? With one another. If I already have credit limit in the model, do we expect credit rating to be useful? How many of you guys think it'll be useful? This is a thumbs up, thumbs down moment, y'all. Show me you're awake, please. I know it's a rainy day. I know it's, I got Sam with a thumbs up. How many of you guys just don't know? All right, let's develop a little bit of intuition here. Let's come back up here and let me remind you, that's the relationship between limit and rating, right? If I already know your credit limit, how much additional information do we think rating is going to give us? A little or a lot? It seems like if I know your credit limit here, I know your credit rating, right? So what information is it adding? Let's find out. So what I'm going to do is I'm just going to fit a model with rating and limit as my predictors, right? Balance is my response. Rating and limit is my predictors. And let me look at the summary real quick on these. Now, the summary we're looking at, what this model now says, let me come down here. it says, I have an intercept. I'm saying balance is equal to negative 293.41 plus 2.228 times your rating plus 0.0113 times your limit. All right, so got these here. Now, what we're going to do is we're going to come over here and we're going to look at these p-values. This p-value asks the question, is the slope for rating 0 given limit is in my model? The p-value says it's right at 0.05. If we're using 0.05 as my threshold, that's above it. So I fail to reject. I can't prove that the slope for rating is not equal to 0. The slope right here, all right, is for limit. What this p-value says is, listen to how I say this. All right, listen to how I say this. What we're saying is the slope for limit equal to 0 when rating is in my model? That's what it's testing. It says, look, the p-value is 0.88, which means, look, it's very likely if the slope coefficient for limit was 0, we would have observed a slope of 0.011. All right. So what this is coming back is saying at the 0.05 level, which is what we talk about significance as, right? Or what I've asked you to. Neither one of these are important. Well, wait a second. When we use this model, when we just use limit by itself, limit was an important predictor of balance, right? So how can we add rating in and limit's importance just disappear? How does that work? Listen to how I say this. When we're interpreting the simple linear regression model, right? When we're interpreting this model, what we're saying is, look, given we increase limit 1 unit, here's how it affects balance. Here what we're saying, given we increase rating by 1 unit, and limit is in the model and held constant. That statement right there, given limit is in the model, the same thing we talk about here when we're saying, look, this is the p-value that the slope for rating is equal to 0, given limit is in the model. The cool thing about multiple linear regression, the cool thing about these models, to me at least, is it knows what other information is available and tries to isolate the importance of that single variable, right? So when we talk about this slope coefficient of 2.228, what we're really saying is, given limits in the model and I increase your credit rating by 1 point, we expect your balance to increase by 2.228. Given limit is held fixed and in the model, given your credit limit did not change. Now, these p-values, what they're talking about is that slope equal to 0 or not, given the other ones already in the model and given that information is accounted for. So let me say this a different way, and one sentence as simple as we can make it. That p-value is asking, given you already know somebody's credit limit, is credit rating important in understanding a balance? Given this p-value, what it is saying is, given you know someone's credit limit already, is understanding their credit rating important? That p-value right there is above 0.05, right? Which says that's not an important predictor. That's not an important variable, given limits already in the model. What's this p-value? It says given rating is already in the model, given you already know someone's credit rating, is their credit limit an important variable? The answer is that p-value is large, that slope coefficient 0. We can't disprove that statement. It's very likely we would observe this if it was 0. So what we say is credit limit's not important given credit rating's already in the model. And credit rating's not important given credit limits in the model. Notice that statement, those conditional statements. And come back up here and look at a picture with me. Remember, when we're building a model, we're trying to build a team, right? Teams need to have unique skill sets from every individual. If I know your credit limit, I basically know your credit rating as well. That's what that plot tells me. You guys agree with that? So what unique skill, what unique information is credit rating actually bringing? Nothing. That's what that model tells me. Are you guys with me on that? What's up, Sam?
So is it fair to make the assumption that if like two variables that you want to put in a graph have a strong like relationship with each other, that they aren't like either like one's not important because they have a strong relationship?
So remember, it's redundant information, right? You're not bringing anything unique to the model. Because remember what that regression coefficient, remember what those p-values are saying, right? You're exactly spot on. You're spot on with what you're saying, but let me take it a step further. It's not the fact that they have a strong linear relationship. We can have linear relationships, but there has to be variability in them, right? There has to be some leftover information because that's what you're trying to leverage. Because when we interpret this model, we're saying, given we already know the credit limit, is rating important? And it's vice versa there, right? It's saying, given we already know your credit limit, is rating important? Given we already know your credit rating, is limit important? When we jump back and forth with those statements, what we're really trying to hammer is, what is the effect here? We know limit. We know from this model we just ran, right? We know from that model right there, credit limit is important in predicting a balance. We know there's that relationship. So when we see it disappear like this, what it's saying is there's not unique information in one of these. So you should only try and use one. Now you come hang out with me in 451. I'm going to teach you some tricks to try and use both pieces of information. But for right now, what we would say is, look, if there's strong linear relationships between two variables, pick one. Pick the one that makes most sense to you, right? Because imagine you're somebody who understands finance a lot better than me, right? Imagine you're Dr. Boyd or Dr. Speaker or Dr. DeGeorge, right? One of the things we're looking at here, one of the things we're thinking about here, when we're looking at this is what makes most sense. And you can be bringing in two pieces of information, okay? You can be bringing in multiple pieces of information simultaneously. So when you're looking at this, when you're thinking about this, it's which one will make the most sense when you put it in your model. Are you somebody who wants to use credit rating, or you want somebody who wants to use credit limit? For me, I'd probably use credit limit because it seems like something, if I'm the one offering the credit card, I can control, right? Yeah, it should be based on the credit rating, but that information's already in there. Now, what I want to do is I want to take one more step here. And I want to introduce you to a homework problem you guys are going to hear for this section. With this same data set, with everybody who has a balance already filtered out, okay? You guys will see every now and then when we do an example here, I'm going to bring it up in a homework problem. All right? This is what you get for coming to classes. You get to ask questions early about homework problems. All right? So the thing I'm going to ask you is, we know rating and limit shouldn't go in a model together. But there's a bunch of other variables here that can. I want you to fit and understand a model. I'm going to ask you to use age, and I'm also going to ask you to use education as it relates to balance, and talk to me about their importance, okay? Now, like anything else we've talked about, we can use added variable plots. We're just going to confirm what we did. All right? What's this? This says, what's the relationship between balance and rating given we've already accounted for limit? If there's a strong linear trend here, there's a relationship. If not, there's not. This is a visual interpretation of what we say when we talk about regression coefficients. All right. We can also use this effects plot. The effects plot in a multiple linear regression piece. Okay. What we're doing is we're saying, look, given limit is set to its average, how does rating affect balance? Given we just set limit at the average limit, what's the relationship between rating and balance look like? Given limit is already in the model and fixed. So without moving somebody's credit limit, if we just change their rating, here's what their balance looks like. Okay. Now take a look at this. Given somebody's rating is in the model and we start moving their credit limit, here's how it affects balance. We fix their rating at the average rating and just move their limit. So as limit goes up, we see a slight increase. But look at those big blue shaded areas. That's my confidence interval, right? It says, well, it can be any there. If you can put a flat line in the confidence interval, y'all, what it says is that predictor is not important. See how I can just draw a straight flat line across there and it be in that blue interval? It says it's not important. Now this one, it gets a little hairy. I can draw a flat line in there, but it may not completely stay in that blue, right? Remember what the p-value was for this. Remember what the p-value was for this. 0.0571. Now you also come hang out with me in 451. We're going to have a little bit deeper discussion about what p-values actually are, right? A p-value is something I say if it's greater or less than 0.05. But what if I ask you about 0.10? That's significant, right? That's significant. At different levels, that number could be significant. So again, it's not always cut and dry. But for right now, we're saying both of these don't matter. Okay? We're saying neither one of these matter. All right? So for your homework, you're going to fit a model with age. You're going to fit a model with education. And limit or rating, your choice. You've got to use one, not both. So you're going to fit two models for me. You're going to fit rating plus age or limit plus age. And then you're going to do rating plus education or limit plus education. And you're going to talk to me about those two models and the effect of those predictors. You guys with me on that? Going to go ahead and give you that early preview, y'all. Now, what we do is we come down and we talk about this. The discussion I just had with you guys is what you'd write down. You say, look, we know limit is an important predictor, but when I look to add rating, the effective limit disappears. Why? Because we only need to know one or the other. Both doesn't help us. Both does not create a better model in this case. All right. Now, let's look at something that will actually help us. Let's go back down here to our transact data. The transact data, remember, what we're looking at is we're looking at the relationship between time and the number of transactions at time 1 and the number of transactions at time 2. Or of type 1 and type 2, I'm sorry. The time it takes to do those transactions. So this is the relationship with time on this, on the y-axis, and the number of transactions on the x. And this is time and the number of transactions of type 2 on the x-axis. So it looks like the time and the number of transactions of type 2 are linearly related. You guys with me on that? With type 1, it looks like it's linear, but we got this thing happening at 0, right? So again, what I want you to think about and what I want you to kind of remember here is what we're doing now. We just learned we need to figure out if two predictors are correlated, T1 and T2. That's this plot right here. All right. That's this plot right here or this plot right here, depending on how you want to look at this. This is T2 on the y-axis, T1 on the x-axis, or this is T1 on the y-axis and T2 on the x-axis. What do you see just visually as the relationship between T1 and T2? So you can use this plot or this plot. Let's focus on this plot just so we're all looking at the same thing. As T2 increases, what happens to T1? If you had to generalize it, does it look like it goes up or down? Sam's going up. Anybody else? Looking at that plot right there. If T2 goes this way, if we take T2 and move it from here to here, would we expect T1 to go up or go down or stay flat? Dominic's going thumbs up, so I'm assuming that's up. Sarah's going up. You could make an argument that it might stay flat, but it's probably going to grow a little bit, right? But these two things are allowed to be related. They're just, think about what we looked at before. These were two predictors that were basically a straight line of each other. You guys agree with that? But when we come back and we look at this, that's not the case here. There's some variability. Yeah, there's a relationship, but there's some variability, right? Remember, we're talking about this as transactions in a bank. My guess is if you have a high type 2 transaction, you're probably a high volume bank anyway. So of course we'd expect T1 to go up. Y'all with me on that? So again, something to keep in mind here. All right. So what I'm going to do is I'm going to fit a model and I'm going to call it M1A, because remember, M1, just as a reminder, M1's this model with just T2 as a predictor. Remember, we said it's a significant relationship. T2 has a significant relationship with time. It's positive. So for every T2 transaction we see, extra T2 transaction we see, we expect another 2.95 minutes of time that day, okay? What happens when I add T1 in though? Well, let's look. I want to do the visuals first, okay? Before we look at the summary, I want to do the visuals. What's this visual? This visual says, what's the relationship between time when I account for T2 or all the other variables in the model and T1 given all the other variables in the model? What this is plotting is the unique information that's left over in time when we have T2 in the model and the unique information that's left over from T1 when we account for T2. So that linear relationship we have between T1 and T2 is being pulled out and saying what's left over that you need to try and explain. If there's a relationship, T1's an important predictor. See that blue line right there? That's telling me T1's an important predictor. We come over here. This is that same plot for T2. All this is saying is, given I've pulled out any information that's in T1, what's the unique information in T2 that's not in T1? What's the unique information that's in time that's not in T1? And are those two things related? The relationship between that leftover unique information is what we're trying to exploit. Basically, what this plot tells me is both of them are significant. Both of them are going to be important predictors. Now, let's use it to verify. When we come in here to verify, the first two things we look at these p-values. What this is telling me is T1's an important predictor given T2's in the model. That's testing what? That's testing, is the slope coefficient for T1 0 given T2 is in the model? That's saying that p-value is less than 2 times 10 to the negative 16. So a really small number. So what are we looking at? We're saying, look, given T2 is in the model, T1 has a significant relationship with time. That's what that plot just showed me too. Come down here, look at this p-value. We're saying, look, that p-value is really small. What happens? We say, look, T2 is an important predictor given T1's in the model. So what's it come out to be? So what I'm saying is time is equal to what? 144.36. Let's just do 7 plus T1 or 5.462 times T1 plus 2.035 times T2. That's all we're saying there. That's all we're saying there. Okay. So what's that mean to us? That means for every T2 transaction we see, given the number of T1 transactions don't change, we expect an increase in time of around 2.03. So about 2 minutes and 3/100ths of a minute. Can't say 3 seconds because seconds are 60, right? So you can say 2.03 minutes. What this means, My slope for T1, it says leave T2 fixed. If I increase the number of T1 transactions by 1, so have an additional T1 transaction, what we're seeing is I expect time to go up by about 5.46. So what that tells me is T1 transactions cost me about 5.46 minutes on average, and T2 transactions cost me about 2.03 minutes on average. That's an easy statement when I'm doing planning, right? I come back and I say, look, I need to plan for this many, given these are my average transactions that occur. All right. Now, here's a cool way to explain this to somebody. If we use these effects plots, and I know these are going to look crazy to you guys, there's a difference between an effects plot and an AVP. AVPs are about unique information. Effects plots are about impact of the variable. Okay. It says, look, given T2 is fixed, for every additional T1 I have, this is the growth I'm expected to see. This is the rate of increase in time. All right. Given T1 is fixed, this is how T2 affects my time. And the gray lines are my confidence intervals, where we're saying, look, it could occur in any range here. You guys with me on that? Now, again, this is something that comes up over and over again, okay? This is something that comes up over and over again, is how are we going to interpret these plots? All right? How are we going to interpret these plots? How are we going to think about what happens here? All right? I told you guys we were going to stop a little bit early today. Does anybody have questions about this? Because I want to give you a chance to ask some questions or for clarifications or anything like that. And again, this is on next week's homework. So if you have questions on this week's homework, we can answer those too. But again, for right now, does anybody have any questions? Or do you guys want to wait until you get in the homework and start modeling a little bit? Because you're going to have you're going to have one data set to work on this week. 2 questions on the credit data set. That's what we're going to do, okay? Because again, I really want you focused on interpretation. I really want you focused on what these things mean and how we use them. You guys with me on that? Any questions? Like I said, I got a 3 and a 6-year-old. I can wait y'all out. Seriously, y'all, if you need help, if you have questions, if you're having trouble knitting your RMD, yell at us. More than happy to help you with that, okay? But with that said, I know it's Halloween weekend. Remember, the internet's a thing. People can search for you. Be smart. I'm going to sound like a total dad for a second. Make good choices. But again, stay safe, stay healthy. All right. Enjoy your weekend. And we'll see y'all next week.
I do have a question if you have a minute.
Yeah, give me a...
I'm just still a little bit slightly confused on how you're explaining the added variable plots and like what they mean in terms of like when you say considering that like they add this one, this like yeah, I'm just a little bit confused.
So think about this. Think about it this way. Let's just look at this one. And you can still see my screen, right? So imagine I could take out all the information that's shared between T1 and T2, right? And then come back and ask the question. All right. And come back and ask the question. What does T1 actually do given I added T2 to them on, right? Given I can explain everything that's in T2 and I've already pulled that information out. What does T1 actually bring to the table, right? So think you're dividing up a group project, right? And you have these skill sets and you're saying, okay, I've checked this box. I've checked this box. Here's what I still need to do to make the outcome work, right? And this would take care of all that. So what you've done is you said, what leftover work do I still have to do? That's what these plots are defining. They're saying, look, see how T1 was always positive? What it's doing is it's bringing the residuals in. This is a plot of the residuals of the regression where T1 is the response and we've taken all the shared information of T2 out. These are the residuals where time's the response and we've taken all the, and T2 is the predictor. So what we've done is we've adjusted both of these variables for the information that T2 shares. And we're looking at the unique information that T1 brings that's left over. Does that make sense to you?
Yeah, so like all the data points you see is what T1 brings that like T2 doesn't show, but what does the line represent?
The line actually represents the slope between those two variables. So it's just the slope of these new two variables we've created, right? That slope of that line is actually the slope coefficient in the regression model. So if you come back and you check the slope of that line, it'll be the slope. So that's for T1. The slope of that line is going to be 5.4. Okay. Because that's what the regression coefficient actually means. Because remember how we're interpreting it. I'm saying this is the impact if we add T1, another T1 transaction, given T2 is already in the model, right? That given T2 already in the model means it already knows all the information that it can from T2. So what it's trying to do is isolate the individual impacts. Like I said, you can use the AVPs if those make sense to you. I'm a visual person, so they do to me. If they don't to you, the interpretation we have for slopes is the exact same interpretation. The thing I tell you at that point, if you're going to use a visual, use the effects plots, because that's just the line, right? That talks to me about what a prediction is. And truth be told to you, I know it sounds crazy. I've used an effects plot 3 times in the past 2 weeks for like research and impact related purposes. So we're submitting a paper on hospital operations, actually 2 of them. And I've got 2 effects plots in one and one in the other, because it has that nice interpretation where you can like isolate a variable, right? And talk about what impact it has. Does that make sense to you?
Yes, it does. Thank you so much.
Again, when it comes to this stuff, and since 3 of you are still on here, I'll say this, and you guys can spread it around the group, and I'll say it again on Monday. When I give you tools like this, we're going to give you the option where you have to use one or the other in a homework. I'm not going to make you use all of them, so you can figure out what makes sense to you and how you are going to discuss it. Does that make sense? Awesome. Awesome.
And Brad, I kept recording during that because I figured it would be helpful for others as well.
I agree. I agree.
Yep.
All right, you guys have a good weekend, and just get back to me, Catherine, when you figure that out.
Yep. Will do.
All right, bye.
See you guys.
Bye.
Krish, everything good?